Welcome to another episode and also another video. And you're here with Mr. T Farming Simple. Alright, and please remember to like. So, the name of our channel is Mr. T Farming Simple. And please remember to like, subscribe to the channel, and hit that notification bell so you'll be able to receive all the upcoming videos, and also you'll be able to view all of my live streaming. Alright? And so today we will be looking at the biogeochemical cycles. The biogeochemical cycles. The biogeochemical cycles. And I really want to take time out to explain fully the concept of the biogeochemical cycles. Alright? The concept of the biogeochemical cycles. So now, first up, I always like to give a little definition as it relates to our topics. Alright, and looking at the biogeochemical cycles, I have derived a little definition. Now, the way in which nutrients, water and also nutrients is cycled in the biosphere is known as the biogeochemical cycles. Alright, so we're going to formulate a definition. So the way in which an element or a compound the way in which an element or compound recycles nutrients and water. Water is also a part of the nutrient cycle. So we can just simply put nutrient. And this happens in the nutrients in the biotic and abiotic world. And biotic means living. Biotic. So this is non-living. And this is living. So the biotic and the abiotic world. So now the way in which an element or compound recycles nutrients in the biotic and the abiotic world, or the living and the non-living world. Alright? And this, okay, as we know that our living world now, we here Earth, we classify this as the biosphere, alright? So now or the biosphere, or the biosphere. And the biosphere now is where biosphere, this is the global ecosystem that also trade nutrients also. So this is a global ecosystem. This is a global ecosystem. This is a global ecosystem of living and non-living, or as I said before, of biotic and abiotic factors, biotic living and non-living factors. So biotic and abiotic factors from which energy and nutrients is derived. So now we are at a little stage now where we understand clearly the concept of the biogeochemical cycle. So the way in which an element or a compound recycles nutrients in the biotic and abiotic world, or in the biosphere. Alright? So this, the biosphere, as I said before, that's the biosphere. The biosphere is a global ecosystem. Alright? So and an ecosystem is a composure. An ecosystem is a composure of all of more than one habitats. Alright? An habitat, so ecosystem, as we go along, because I want it to be on all of us to be on the same page, I will disclose a few definitions as we go along, because I really want us to be on the same page. Alright? So an ecosystem now, a simple definition for an ecosystem. So ecosystem an ecosystem is a composure or you could say this is a combination of more than one habitats. Alright? So this is a combination of more than one habitats. So now also habitat Habitat now is a place where organisms live. This is a place where organisms live. So an habitat, so now we are clearly understanding now the concept of the biogeochemical cycles and how an element or compound recycles nutrient within the biotic and the abiotic world. The biosphere, this is a global ecosystem of living and non-living factors from which energy and nutrients is derived. Also, the ecosystem, this is a combination of more than one habitat, and we've learned now that habitat is a place of residence for organisms. All right. So there are a lot of biogeochemical cycles, but today I'll just touch on maybe about 4 if I have enough time, because I won't keep you long today. I'll just touch on about 4. So I'm going to give you a few seconds to maybe, or you can always go back and pause the video and have your notes being written down. And do your proper jottings. So the first of our biogeochemical cycles now we'll be looking at, or I'll just give you a list of the biogeochemical cycles. So the first is the water cycle. Two, we have the nitrogen cycle. And 3, have the carbon cycle. And 4, have the phosphorus cycle. Phosphorus cycle, alright? So we have the water cycle, the nitrogen cycle, the carbon cycle, and the phosphorus cycle. So those are the 4 main biogeochemical cycles. So the first one we'll be looking at is our water cycle. Alright? First one we'll be looking at is our water cycle. Okay, so first up, we're learning a lot today on this topic, on the water cycle. Okay, so now we have water, which is H2O, and the H here is for hydrogen, And this is also known as the hydrological cycle. So even if you are doing an exam or the such like, and they refer to the water cycle as the hydrological cycle, it's the same thing. It's the water cycle they're referring to. Alright? So now we have H2O. So now we have H being hydrogen and we have O being oxygen. Alright? So two wonderful elements. So hydrogen now it's the first element in the periodic table, and so oxygen would have fallen. So you have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. So oxygen would have fallen 8 in the periodic table. Further, I'll teach you. I'll show you a little trick in knowing those. The chemistry section of this. So just bear with me and follow my videos, and you'll learn a lot of chemistry also. Alright, so water now is made up of two main elements. So we have hydrogen and oxygen. So hydrogen is also a gas and oxygen also. So hydrogen and oxygen. So during this calculation, we have H2O, so the 2. So it has 2 hydrogen atoms and 1 oxygen atom. So wherever you see a single letter, it indicates or signifies 1. So it's H2O. So 1 atom of oxygen, sorry, and 2 atom of hydrogen. That gives us a water molecule. All right. So now we understand the basic creation of a water molecule. So now we want to understand the quantity or volume of water here on Earth. Alright? So now, the quantity or amount of water on Earth. Alright? So the quantity or amount of water here on Earth. So approximately 70 So approximately 70 to 75% of Earth is made up of water. And pay attention keenly to this percentage now. And I'll be showing you now a distinction now between the saline quantity or volume and also the freshwater volume. Alright? So now, saline volume or water from ocean. From ocean. So this adds to 97%. So 97% of the earth contains salt or saline water, and 3% so fresh water available to us is actually 3% of that of that 100%. So the 97 would allot it to saline or salt water. Alright? So now we understand the quantity and also the volume of water available to us. So now we're going straight into the actual cycle. And water, as you all know, water is essential to life. Water it has a lot of properties. So in another video I'll go through some of those properties. It's a universal solvent. I'll just explain that before I do the cycle, because I don't want to stray too much from the topic of the biogeochemical cycles. All right. So in another video, maybe another topic will pop up for me to explain the different properties of water. All right. But this is very critical for you to understand that water is a universal solvent. Universal solvent, which means that water is almost used in almost 90% of some of these compounds are most of the things that we are making, chemicals, whatever we are producing, water has to be a part of the production. Alright? So that's the reason why it is called a universal solvent. That's the reason why it's called a universal solvent. So now we are going to draw this water cycle. And before I draw this water cycle, I would like to just scratch the steps within the water cycle. So the first step is known as step 1, steps. Steps in the water cycle. So step 1, evaporation. Evaporation. 2, condensation. You have evaporation, condensation, and you have precipitation. Alright, and also you can put another one, this is called evapo. This one is known as evapotranspiration. Alright? And this is basically, evaporation is done when sun, this is when This is when the sun now heats any available water and brings it to the atmosphere. Alright? So I will show you definitely in the cycle when I'm drawing the cycle. So the sun heats the water, whether you're cooking, whether you're spilling water on the ground, whether from the ocean, rivers, lakes, streams, anywhere. Evaporation, and it goes up as steam or gas. And now condensation now. So the molecules that has been there in the atmosphere reaches in the atmosphere now. These molecules, they're compact molecules now. Compact molecules form clouds. Alright, okay, form clouds. So after the formation of these clouds now, with these small water molecules, then precipitation is rainfall. And evapotranspiration now, this is water being evaporated from leaf. Water being evaporated from plant leaves. Alright? So we'll just go straight into our cycle now. So now we understand the steps in our water cycle. So I'm not a good artist, but I'm sure I can help myself to draw this water cycle. So the water cycle. Cycle. All right. So first up, we have, all right, I'm just going to draw. So we have our mountains. Alright, so we have our mountains. Alright, and this one. So this is our mountain. This is the surface runoff, and this here on the bottom we have our ocean. So start the labeling. So here we have our ocean. Alright. We can have this. Alright, so we have our ocean. And then from there, so we can have a few plant trees here. So we have tree, and we have the so we have this now. So this is the process of condensation. I'll show you when I'm finished. And these are some water droplets on the leaf for the evapotranspiration process. And then we have another set. Includes. Okay, so now we'll be working with a few arrows now. So there is evaporation. So the sun plays a very important role in this. The sun plays a very important role because evaporation cannot take place without the sun. So the sun heats all of these and they evaporate. So the process of evaporation. So here is evaporation. I'm trying to take with this one. That's evaporation. And evaporation now is going up, as I said before. And now from evaporation now, there is so here is condensation. Condensation, all right? And from condensation to precipitation. Precipitation, all right? And right here you would have had your surface runoff from your mountains. Surface runoff. And here you have your ocean and your mountains. Mountains, where mountains, lakes, rivers, stream, wherever. And this, last but not least, we have evapotranspiration. So evapotranspiration, as I said before, is the removal of water from plant leaves. So that is evapotranspiration. Evapotranspiration. So now here we have our water cycle. Simple explanation. So we have our water bodies, as I said before, can be a well. There can be a well in your neighborhood. That contains water. However, still goes in the process of evaporation. Water is leaving there, whether microscopic or you can see it when the sun is very hot. Water is still leaving through the process of evaporation and following condensation, then precipitation, after which rain falls, and the cycle continues. Alright? So it's a very simple cycle to understand. The hydrological cycle or the water cycle is simply explained. Evaporation, condensation, precipitation, then you have your woodlands or your mountains, your forests, watershed areas, surface runoff. During those areas, water goes underground water table. Here we have our ocean, and the cycle continues. Alright, so that's it for the water cycle. And so now we will be looking quickly at our nitrogen cycle. And these are very important cycles for you to understand, especially for those who are actually doing exams. We have external exams coming up. Very important. If you're doing environmental studies, if you're doing straight biology, if you're doing integrated science, human and social biology, these cycles are very critical and crucial for you to understand. So don't take these cycles for granted. During your exams, you need them because you need to understand clearly how the biotic interacts with the abiotic or the living world, benefit from the non-living world. Alright? So next up we have our nitrogen cycle. Nitrogen cycle. And first, nitrogen exists in the atmosphere as a gas. Nitrogen exists in the atmosphere as a gas. Alright? Nitrogen exists in the atmosphere as a gas. So we're talking about now the importance of nitrogen to both plants and animals. Alright, so we cannot utilize nitrogen in its gaseous state for our consumption, as well as plants definitely cannot utilize it. So therefore, it brings about a cycle. So we'll be looking at that just now. So nitrogen exists approximately 78% of the Earth's atmosphere is nitrogen. So nitrogen exists approximately 78%. So N2 is the actual nitrogen gas. So I'm approximately in the atmosphere. So approximately 78%. So approximately 78% of the Earth atmosphere is actually nitrogen gas, or N2. Alright? So as I said before, we cannot utilize or consume nitrogen in its gaseous state. So in order for it to be beneficial to us, or for it to help us, we have to figure out a way or identify some steps where, because it occurs naturally. So we have done our research and know how we actually consume or utilize nitrogen. So nitrogen exists in the atmosphere as a gas. So now there are some first stage in the first step in it, steps in the nitrogen cycle. So step 1, nitrogen fixation. Step 2, you have nitrification. Three, you have assimilation. And 4, of modification. And 5, of denitrification. So these are the 5 steps of the nitrogen cycle. So I'll just simply explain all of these shortly, because I'm going to maybe get some space on the board. So nitrogen fixation before I start writing. So nitrogen, as we learned earlier, exists in the atmosphere as a gas. So now, please note, bacteria acts or reacts at every level or every stage during the nitrogen cycle. Bacteria enables us to consume nitrogen in a usable form. So during this stage of nitrogen fixation, let me move some of these. So nitrogen fixation. So nitrogen fixation now. Bacteria converts nitrogen gas, which is N2, to ammonia. That's the first step. So bacteria at this stage now converts nitrogen gas to ammonia. That's during nitrogen fixation. Also, in nitrogen fixation, also lightning naturally fix nitrogen. Alright? So the regular lightning that flashes in the cloud, you have a cloud and you have lightning flash. So during that process, nitrogen fixes naturally. Alright, so that's another form of nitrogen fixation. So during the second step in our cycle, which is nitrification. Nitrification. Alright? So bacteria again converts ammonia and please, I'm going to explain further about something about ammonia. So bacteria converts ammonia to nitrate. So now we finally seeing something that is usable to plants, because plants absorb nitrate. So now ammonia is very toxic, so therefore plants are unable to utilize ammonia in its natural state like that. So then a set of bacteria is there to convert ammonia to nitrate. Alright? So now the third stage, is assimilation. In this process, bacteria or plants, plants finally get an opportunity to absorb nitrate. So plant finally get an opportunity to absorb nitrate. So nitrate is moving up in the plant. So and nitrate is coming directly from nitrogen gas. So we understand the different conversions coming down. So now we also have a modification. This is where plants use bacteria to break down. This is where plants use during this stage of ammonification. Ammonification now. So whenever plants and animal dies, right, bacteria breaks down with decomposers straight back to the soil. So I'm going to explain that differently to you now, because I had some notes on ammonification. So, but I'm going to put it differently to you so you can better understand it. So after plants now finally gets an opportunity to absorb the nitrate, alright? So now we have ammonification. So the same plants now, plants dies and also and decays. Plants dies and decays, and nitrogen reaches the soil. So because after plants, after the absorption of nitrogen, these same plants now dies and decays, and the nitrogen nutrient reaches back to the soil. So the last stage in this now is the denitrification. During this now, bacteria or anaerobic bacteria reacts and convert nitrate to nitrogen gas. So this is the final stage. So nitrogen finally now is being converted from nitrate straight back to nitrogen gas, and it reaches back into the environment. Alright? So it reaches back to the environment. So anaerobic, this is the use of breathing with little or no oxygen. So aerobic is the use of oxygen, and anaerobic is the use of little or no oxygen. So now we understand the different steps within the nitrogen cycle. So now we are going to quickly draw the nitrogen cycle. So if you are asked to draw the nitrogen cycle, it's simple for you to do. Alright? So we have N2 in the environment, alright? Nitrogen in the environment. And we also have, alright, our plants. Let me see. Alright, so we have our plants. And also, and so we have our plants and we have our animals. So we also have lightning. And we also have animals. I'm not, I can't draw this way, you know. This is an animal eating. So plants and animals. So we have our plants and we have our animals. I'm trying to set it out. So we have our plants, we have our animals. Alright, so it's two sides to it. So now we have denitrification on this side. Simply two sides to it. And nitrogen fixation on this side. Alright? So denitrification. Denitrification and now nitrogen fixation. Alright, so nitrogen fixation. And then now you have bacteria here. An next set of bacteria here. Another set here. I'm going to look at something. So, and another set here. So now we have nitrogen fixation. So nitrogen fixation and denitrification. So we have so here we have nitrification. I'm trying to write it somewhere again. So these are where the bacteria are working. Different bacteria. So we have nitrification. Nitrogen fixation, nitrification. And then you have ammonification. Assimilation, sorry. And assimilation can be either here and because I don't want to mix it up, you can have assimilation coming from here. So you can have your plants here. And once they have converted, so we have nitrification, so you have ammonification here. Ammonification here, alright? So from ammonification, now, so you have nitrogen fixation, nitrification. So doing this, so nitrification should have been here. So nitrification. Nitrification and ammonification. Nitrification, nitrification. modification, and here we can have the assimilation. Assimilation, as I said before, this is where the plants get the opportunity to absorb the nitrate. Alright, so assimilation. Assimilation. And finally, there you have the denitrification. Bacteria also again converting nitrate to nitrogen gas. That's during the denitrification process. So the nitrogen cycle simple to understand now. So you have lightning flashing, fixing nitrogen also. So nitrogen fixation. We have from there, we have nitrification, nitrogen fixation, nitrification, ammonification. Remember, ammonification is where the plants die and decay, and bacteria acts at this step, and then now we have plants absorbing nitrate, the form assimilation going up, and then denitrification process. This is where the anaerobic bacteria takes place. Alright, so for instance, in your pit somewhere close or under the soil, underground somewhere where there are a lot of dead and decaying organisms or organic materials are being covered up. So in other words, they are being stifled. So there are certain bacteria that acts at that stage. So after that, nitrogen exists again in the atmosphere as a gas after that final process. Okay? That final process. So now I think I'm going to have to stop here for today, because we have our carbon cycle and also our phosphorus cycle. But I think due to the different definitions, I have to, because this is how I teach, I have to explain definitions as I go along, because I really want everybody to be on the same page and actually understand, because I came today to fully disclose and completely identify all the different biogeochemical cycles, but we weren't able to do that and cover that. So on our next video, which should be next Saturday, same time, we will resume the biogeochemical cycles, because different topics as it relates to farming and also biology and also sciences and their relationships with the biogeochemical cycles. So thank you, and please remember to like, subscribe to my channel and share this video so Mr. Thompson will be able to continue with this good work. So thank you very much.